Hi class, I want to talk to you about expected value of perfect information. This is not to be confused with sample information, which is another concept related, but it's a completely different concept. Um, Perfect information clearly does not really exist. You're never 100% sure of something. You never really know absolutely everything there is to know. But we need to assume this concept just for to do some calculations about potential value of a specific decision. So here I have, this is a problem from chapter 4. This is the exact same problem where we have three different decisions and two different states of nature: strong demand, weak demand. One has 80% chance of happening, which is a strong demand. Weak demand has a 20% chance of happening. So what I've done is I took this table, okay, which is exactly the one on your textbook. And what I did is I actually just pivoted, right? I just transpose the fields and the columns, and I get a completely different view of the problem. Okay, what we're saying with this new table is that if the demand is strong, then the best alternative, the best option, is to build large. If the economy is weak, the best alternative is to build small. You probably already knew that. You just didn't write it down, right? Like on a grid, like I just did. But that paints a completely different picture. If you knew for a fact that the demand was going to be strong, you will build large. If you knew for a fact with perfect information that the demand was going to be weak, you will build small, right? Because if the demand is weak and you build large, you will lose 9. But you know that it's going to be weak, so why will you build large? You will choose the option small and make 7, which is better than 5 and definitely a lot better than -9. If you know for a fact that the economy is going to be strong, that it's going to improve, then you're going to build large because 20 is more than 14 and is more than 8. And assuming you're a rational individual and you want to make more, you will pick this option. Okay? So this is the value with you if you had perfect information. But the probabilities of each of these two scenarios are still 80% and 20%. It's just that you now have 100% assurance of which one is going to be. You will know when that happens, you will know for sure which one is going to be. But the states of nature have not changed. The fact that you know which direction the economy is going to go does not affect the way the economy is going to go. You don't have that power. The economy still has an 80% chance of going up and a 20% chance of going down. It's just that you're going to know ahead of time exactly what's going to happen. So if we could calculate the expected value with perfect information, then we could compare our current expected value of the whole problem versus what would be the expected value if I knew for a fact. Well, in other words, what's the most I could ever make in this situation if I knew absolutely everything? Because this is what I've done. Right here in this cell, we have the formula. And the formula is quite simple. You will multiply the value of each of the strategies, which in this case you only have 2 strategies, either complex or small, because you know that you're going to build either complex or small based on these numbers. So you're going to multiply the gains, the earnings from the first option, which is large, times 0.8, because again, there's still a 0.8 chance, 80% chance that the economy is going to go up. And you're going to add the value of the other option, which is build small, when the economy goes down. And the economy has a chance of going down at 20%. So you multiply by that. The math is simple, 17.4. That means that if you had perfect information ahead of that decision, before you make that decision, the expected value, the theoretical value of this operation will be 17.4, which obviously is higher than the previous one of 14.20. That's when you didn't have perfect information. So what is the value of perfect information? Not the expected value. The expected value will be 17.4. But the value itself, how much is perfect information worth to you? Simple. It will be the difference between the value, the expected value of the project with perfect information minus the expected value of the project without perfect information. So that's 3.2. And I would like to pause, but I don't have to pause because it's a video, so there's no point. You can pause it, right? But think about that. 3.2. What is that 3.2? 3.2 is the amount of money you're not earning because you don't have perfect information. So if you can somehow get perfect information, you could get 3.2 more. That means that you are willing, or you should be willing, to spend money to do whatever it is that you need to do to get that perfect information. By how much? How much effort should you spend? How much money should you spend on getting this theoretical perfect information? Easy. The most you should spend on it would be what? 3.199999, whatever that number is, right? If someone comes to you and tells you, hey, I have perfect information, I'll give it to you for 3 million. You should absolutely do it. Because if someone gives you perfect information for 3 million, you could use that perfect information, right? And obtain an extra 3.2. And if it costs you 3, but you obtain an extra 3.2 in benefit, then you'll be ahead of the game. You're still making 0.2 more than you were before. That's the value of perfect information.